If you've been working with Java for some time, you've probably used String, StringBuilder, and StringBuffer. But have you ever wondered why Java provides 3 different classes to store text? In this video, we'll cover string pool, heap versus pool, equals versus double equals, string immutability, performance differences, and most importantly, when to use each one in real-world applications. Let's start with string pool. Take a look at this example. We create 2 string variables containing the same literal value, Java. When we compare them using double equals, the result is true. Why? Because Java stores string literals in a special memory area called the string pool. When Java sees the second literal, it first checks whether that value already exists in the pool. If it does, Java reuses the existing object instead of creating a new one. As shown in the memory diagram, both S1 and S2 point to the same object. This optimization saves memory and improves performance. That's why identical string literals share the same reference. But now let's look at the interview question that confuses many developers. But what if we don't use a string literal? What if we force Java to create a completely new object? Take a look at this code. String S1 equals Java. String S2 equals new string, Java. At first glance, both variables contain exactly the same text. So what do you think the output will be when we print S1 equals S2? Will it still be true? This is one of the most frequently asked Java interview questions. The answer is false. Why? Because S1 points to the object stored in the string pool. But when we use string S2 equals new string, Java creates a brand new object in heap memory. So now we have 2 different objects containing the same content. And that's the key difference. Equals equals compares references. Dot equals compares content. Therefore, S1 equals S2 returns false because the references are different. But S1 dot equals S2 returns true because the content is exactly the same. A good interview answer is: same content does not mean same object. Always use equals when comparing string values unless you specifically want to compare object references. Now that we understand how string objects are stored and compared, let's see why Java introduced StringBuilder and StringBuffer. Unlike string, both StringBuilder and StringBuffer are mutable. That means their content can change without creating a new object. For example, append method modifies the same object repeatedly. This makes them significantly more efficient when you're building or modifying large amounts of text. So what's the difference? StringBuilder is not thread-safe. Its methods are not synchronized. As a result, it delivers the best performance. StringBuffer is thread-safe. Its methods are synchronized, making it safe for multi-threaded environments. The trade-off is slightly lower performance. A simple rule to remember. Single thread? Use StringBuilder. Multiple threads? Use StringBuffer. Now let's understand why string itself was designed differently. One of the most frequently asked Java interview questions is: why is string immutable? Let's see what happens here. We start with string s equals Java. Then we concatenate another value. Did Java modify the original object? No. Java creates an entirely new string object. The original object remains unchanged. But why did Java's designers choose this approach? There are 4 important reasons. First, security. Sensitive information such as database URLs, file paths, tokens, and credentials are often stored as strings. Immutability prevents accidental modification. Second, thread safety. Immutable objects can safely be shared between multiple threads without synchronization. Third, string pool. The string pool works efficiently because pooled objects cannot change. Otherwise, changing one reference could unexpectedly affect many others. And fourth, HashMap performance. Strings are commonly used as HashMap keys. Since their value never changes, their hash code remains stable. That's critical for fast lookups. These 4 reasons are worth remembering because they appear frequently in interviews. Now let's talk about performance. Suppose we build a string inside a loop. Every concatenation creates a brand new string object. If this happens hundreds or thousands of times, Java ends up creating a huge number of temporary objects. That means more memory usage, more garbage collection, slower execution. Now compare that with StringBuilder. Instead of creating new objects repeatedly, Java modifies the same object. Only one object is maintained throughout the operation. That's why StringBuilder is dramatically faster for frequent string modifications. In real-world applications such as log generation, JSON creation, XML processing, report generation, or large text construction, StringBuilder is almost always the preferred choice. Performance-sensitive code should avoid repeated string concatenation inside loops. We've covered all the concepts. Now let's quickly revise the most important interview questions from this topic. Question 1. Why is string immutable in Java? A complete interview answer should include these 4 points: security, thread safety, string pool optimization, and reliable HashMap keys. If you mention all 4, that's usually considered a strong answer. Question 2. What is the string pool? The string pool is a special memory area where Java stores string literals. When the same literal appears again, Java reuses the existing object instead of creating a new one. That's why string s1 equals Java, string s2 equals Java. Both references point to the same object. Question 3. What is the difference between double equals and equals? Double equals compares object references. Equals compares content. This is one of the most commonly asked Java interview questions. A simple memory trick. Reference comparison? Use double equals. Content comparison? Use equals. Question 4. What is the difference between StringBuilder and StringBuffer? Both are mutable. Both are used for modifying strings efficiently. But StringBuilder is faster because it is not synchronized. StringBuffer is thread safe because it uses synchronization. Simple rule. Single thread? StringBuilder. Multiple threads? StringBuffer. If you're comfortable answering these 4 questions, you've already covered a large portion of the string interview topics asked in Java interviews. Let's look at a few more advanced questions. Question 5. Why is StringBuilder faster than string? String objects are immutable. Every modification creates a new object. StringBuilder modifies the same object repeatedly. That's why it uses less memory and delivers better performance. This is especially important inside loops. Question 6. Why is string commonly used as a HashMap key? Because string is immutable. Its value never changes after creation. That means its hash code remains stable. And a stable hash code is critical for fast and reliable HashMap lookups. This is one of the most frequently asked Java collections interview questions. Question 7. What happens when we create string using new keyword, for example string s equals new string, Java? Many developers think only one object is created. But that's not always true. If Java is not already present in the string pool, Java creates one object in the string pool, one object in heap memory, potentially 2 objects. This is a favorite interview question because it tests understanding of string pool internals. Question 8. Can StringBuilder and StringBuffer use the string pool? No. The string pool stores string objects only. StringBuilder and StringBuffer create normal objects in heap memory. They do not participate in string pool optimization. Bonus interview question. Which one should you use in real projects? The answer depends on the use case. For fixed text, use string. For frequent modifications, use StringBuilder. For multi-threaded modifications, use StringBuffer. Choosing the right class is more important than simply memorizing definitions. And with that, you've covered some of the most frequently asked string interview questions in Java. If you're preparing for Java interviews, save this video and subscribe to Spring Java Lab for Java, Collections, Spring Boot, JPA, and Backend Development content.